March 20th, 1945. Haustenbeck Testing Grounds, Germany. Major Russell Smith stared at what American intelligence had called impossible, a 70-ton Jagdtiger sitting abandoned in perfect working condition, not destroyed by enemy fire, not sabotaged by retreating crews, simply out of fuel. The massive tank destroyer stretched before him like a steel cathedral, its 128-millimeter gun capable of penetrating any Allied vehicle at over 2 miles. German engineering at its absolute peak. Smith had spent months cataloging destroyed Wehrmacht equipment, always finding the same story. Brilliant technology undone by basic logistics. But this Jagdtiger was different. Intact, operational, a chance to test everything American doctrine believed about the German approach to armored warfare. As technician Wharton ran his hands along the pristine armor plating, he noticed something that made Smith's blood run cold. Fresh tire tracks leading away from the vehicle. Deep ruts where 70 tons had sunk, axle deep in ordinary mud. The kind of terrain a 30-ton Sherman could cross without hesitation. The Germans hadn't abandoned their ultimate weapon because of Allied superiority. They had been defeated by something far more fundamental, the laws of physics themselves. Major Russell Smith stepped over the twisted remains of a Panzerfaust launcher, his boots crunching on shattered glass from the testing facility's blown-out windows. The acrid smell of cordite still hung in the March air, 3 weeks after German forces had abandoned Haustenbeck. Smith had cataloged destroyed Wehrmacht equipment across 2 theaters of war, and the pattern never changed, ingenious engineering rendered useless by logistical collapse. Tiger tanks with their final drives stripped for parts. Panthers abandoned when their transmissions failed. Each piece told the same story of German ambition exceeding German capability. But the vehicle waiting in the concrete testing bay defied that pattern entirely. "Jesus Christ," whispered technician 5th grade Charles Wharton, running his calloused fingers along the Jagdtiger's frontal armor. 250 millimeters thick. I've seen Sherman shells bounce off Panther glasses. But this? He knocked his knuckles against the steel, producing a dull thud that spoke of massive density. This thing could stop a battleship shell. Smith walked slowly around the tank destroyer, notebook in hand, comparing the vehicle against intelligence reports that had dismissed it as German fantasy. 70 tons of operational steel contradicted every assumption. The Jagdtiger's sloped casemate rose like a medieval fortress, its 128-millimeter PaK-44 gun jutting forward with mathematical precision. Even at rest, the weapon radiated lethality, its bore diameter larger than most howitzers, designed to fire 28-kilogram shells at velocities that could punch through any Allied armor at distances exceeding 3,000 meters. "Sir, you need to see this," called Sergeant Bill Kowalski from behind the vehicle. The recovery specialist stood beside deep track impressions in the muddy ground, his measuring tape stretched between the ruts. "Vehicle sunk damn near axle deep just sitting here. Ground's not even that soft, just regular spring mud. Sherman would sit on top of this, no problem." Smith knelt beside the tracks, pressing his palm into the earth. Firm soil, the kind that supported infantry movement without difficulty. Yet 70 tons had compressed it into concrete hard furrows that would require engineering equipment to repair. The mathematics were inescapable. Ground pressure of nearly 1 kilogram per square centimeter, double that of American medium tanks. The Jagdtiger didn't just travel across terrain, it deformed it. "Kowalski, what's your assessment for recovering this if it threw a track in combat?" Smith asked, though he suspected the answer would be damning. The sergeant consulted his calculations, lips moving silently as he ran through equipment requirements. 3 M32 tank recovery vehicles minimum, sir. Maybe 4 if the ground's soft. 8-hour operation, assuming we have hard stand to anchor the winches. That's optimistic. He looked up from his notepad. In combat conditions? Forget it. You'd need to build roads just to get recovery equipment close enough. Wharton had worked his way to the rear deck, where German maintenance panels revealed the Jagdtiger's mechanical complexity. Engine's a Maybach HL 230 P30. Same power plant as the Tiger II, but this vehicle weighs 15 tons more. He traced fuel lines with a mechanic's practiced eye. 690 horsepower pushing 70 tons. Power-to-weight ratios worse than a Churchill tank. Smith did the mental arithmetic and felt his optimism deflate. The Jagdtiger's power-to-weight ratio barely exceeded 9 horsepower per ton, compared to nearly 15 for the Sherman. German engineers had essentially strapped battleship armor to a chassis never designed to carry the load. Every mechanical component operated beyond its design parameters, stressed to the breaking point by sheer mass. Fuel consumption? Smith asked, though he dreaded the answer. German manual says 250 liters per 100 kilometers on roads, Wharton replied, flipping through captured documentation. Cross-country? Maybe double that. Sherman burns 94 liters for the same distance. The implications crystallized with brutal clarity. The Jagdtiger consumed fuel at nearly 5 times the rate of American medium tanks, while delivering a fraction of the operational flexibility. In fuel-starved Germany, such consumption rates guaranteed strategic paralysis. Smith had seen the evidence firsthand. Tiger units reduced to single operational vehicles, their sister tanks cannibalized for parts and fuel. As Smith climbed onto the vehicle's rear deck to examine the engine compartment, Wharton discovered something that made him curse softly in Pennsylvania Dutch. "Major, you better look at this." The technician pointed to the drive sprockets, where metallurgical stress had created hairline fractures in the hardened steel. "These wheels are cracking under load, not combat damage, mechanical failure from the vehicle's own weight." Smith studied the fracture patterns through a magnifying glass, recognizing the telltale signs of metal fatigue. The drive wheels, masterpieces of German metallurgy, couldn't withstand the torque required to move 70 tons across uneven terrain. Even in peacetime conditions, the Jagdtiger was destroying itself through normal operation. "How long before total failure?" Smith asked. Wharton ran his fingers along the crack lines, counting stress points with a mechanic's intuition. "Maybe 1,500 kilometers if they're lucky. Sherman final drives are rated for over 5,000. He straightened, wiping his hands on a rag that came away black with metal particles. "Sir, this whole vehicle is an exercise in wishful thinking. They've built something that can't do what it's designed for." Smith opened his notebook and began writing, the words forming with grim certainty. The Jagdtiger represented German engineering at its most sophisticated and most delusional. Every specification impressed on paper while ignoring the fundamental reality that weapons must be transportable, maintainable, and sustainable to achieve battlefield effectiveness. The Germans had created a steel monument to their own strategic blindness. As afternoon shadows lengthened across the testing ground, Smith made his preliminary assessment. The Jagdtiger was simultaneously the most powerful tank destroyer ever built, and a perfect example of why technical superiority meant nothing without operational viability. Tomorrow they would attempt to transport this marvel of German engineering to Aberdeen Proving Ground. Smith suspected that simple journey would prove more challenging than any combat the vehicle might have seen. The monster in the barn was about to teach American forces a lesson about the difference between capability and effectiveness. The first challenge emerged before the Jagdtiger had moved a single meter. Lieutenant Colonel Harold Brennan, the railway transport officer assigned to Smith's operation, stood beside the concrete loading ramp with a clipboard full of calculations that spelled disaster. "Standard flat car capacity is 40 tons maximum," Brennan announced, his voice carrying the flat certainty of engineering impossibility. "Your 70-ton beast exceeds every railroad specification from here to Baltimore." Smith watched as Brennan's crew measured the Jagdtiger's dimensions against a reinforced Schnabel car requisitioned from civilian heavy machinery transport. The specialized rail car, designed for moving industrial boilers and generator turbines, groaned audibly as hydraulic jacks slowly lifted the tank destroyer from its concrete pad. Steel cables thick as a man's wrist strained against the load, their braided fibers stretching visibly under tension that approached their breaking point. Axle loading's the real killer, Brennan continued, consulting stress calculations that covered 3 pages of foolscap. 70 tons concentrated on a 30-meter car translates to ground pressure. That'll buckle standard rail joints. We're talking about rebuilding every bridge between here and Aberdeen, reinforcing spans rated for 35 tons to handle double that load. Sergeant Kowalski had anticipated this problem during his initial recovery assessment, but the mathematics proved even worse than his pessimistic projections. Sir, in combat conditions, you'd need specialized rail equipment just to evacuate a disabled Jagdtiger. That's assuming enemy action doesn't crater the tracks first. He gestured toward the struggling loading operation where 6 men operated winches that normally handled medium tanks with ease. Sherman weighs 33 tons, loads in 40 minutes with standard equipment. This operation's taken 4 hours and we're not even secured for transport yet. The loading process revealed additional complications that German doctrine had apparently ignored. The Jagdtiger's extreme weight concentrated on relatively small track contact patches created point loading that exceeded the structural capacity of most European railroad infrastructure. Bridge surveys conducted by Army Corps engineers indicated that 60% of rail spans between German testing facilities and major repair depots could not safely support the vehicle's weight, even when distributed across specialized cars. As the transport convoy finally departed Haustenbeck, Smith rode in the lead jeep with a growing appreciation for German operational paralysis. Every kilometer revealed new evidence of infrastructure inadequacy. Road surfaces designed for horse-drawn artillery and light motorized transport cracked audibly under the Schnabel car's massive wheels. Concrete bridges dating to the 1920s developed hairline fractures that forced detours through farming villages never intended for military traffic. "Look at this," Wharton called out during a mandatory stop for bridge inspection. The technician pointed to stress damage in the roadway where the transport convoy had passed. "Asphalt's buckling 6 inches deep. Road crews are going to need a full reconstruction just from one pass." He walked alongside the damage, measuring crack patterns with a mechanic's tape. German logistics assumed hardened military roads and dedicated rail transport. They built a weapon that requires infrastructure they didn't have. The mathematics became increasingly damning as the convoy struggled through the Bavarian countryside. Fuel consumption for the specialized transport equipment exceeded projections by 40%, requiring additional fuel trucks that complicated convoy security and further strained roadways. The Jagdtiger, immobilized on its rail car, was consuming resources at rates that made operational deployment economically impossible even before considering combat requirements. Smith studied captured German logistics reports during overnight stops, finding confirmation of his worst suspicions. Wehrmacht heavy tank units reported operational readiness rates below 30%, with most vehicles sidelined not by enemy action, but by mechanical failure or inability to move across standard terrain. The pattern extended beyond individual breakdowns to systemic operational paralysis. Units equipped with technically superior vehicles that couldn't reach combat zones. On the convoy's 3rd day, disaster struck in the form of a 1920s vintage stone bridge over the Neckar River. Corps engineers had rated the span for 35 tons maximum loading, but alternative routes would add 2 days to the journey through mountain passes unsuitable for oversized transport. Brennan authorized the crossing with extreme caution, posting engineers at critical stress points to monitor for structural failure. The Schnabel car crept across at walking speed, its steel wheels transmitting every irregularity in the ancient stonework to the Jagdtiger's massive frame. Halfway across, audible cracking sounds prompted an immediate halt. Engineers discovered stress fractures in the bridge's keystone arch, progressing at rates that threatened catastrophic collapse. The convoy backed off, leaving German engineering excellence stranded on a bridge that German logistics had never been designed to support. 12 hours to construct a temporary bypass, Brennan announced after consulting with his engineering teams. Assuming we can find suitable bridging equipment in theater. He gestured toward the immobilized Jagdtiger, silhouetted against gathering storm clouds. Your superweapon just paralyzed an entire transport corridor. One vehicle, 12 hours of engineering work and resources that could have moved an entire armored company. Kowalski performed calculations that quantified the operational absurdity. Sir, recovery time for a disabled Jagdtiger in combat 8 hours minimum, assuming optimal conditions. Sherman recovery 45 minutes average. Resources required. 3 M32 recovery vehicles versus 1 for standard tanks. Crew exposure time under enemy fire 16 times longer. He closed his notebook with finality that spoke of mathematical certainty. This isn't a weapon system. It's a resource sink designed to defeat your own logistics. As emergency bridging equipment finally arrived and construction began on the temporary span, Smith realized he was witnessing German strategic thinking in microcosm. Technical perfection pursued without regard for practical constraints had created a weapon too sophisticated for the infrastructure required. To employ it effectively, the Jagdtiger represented not advanced military thinking, but the bankruptcy of engineering without wisdom. Aberdeen. Proving Ground's firing range echoed with the distinctive crack of the Jagdtiger's 128mm gun, a sound that seemed to split the Maryland air itself. Smith stood behind ballistic shields watching through periscopes as 28-kilogram shells obliterated target after target with mathematical precision. The weapon's performance exceeded even optimistic projections, penetrating mock-ups of Sherman, Pershing, and Soviet T-34 hulls at ranges that rendered Allied armor effectively defenseless. Muzzle velocity 2,950 feet per second, announced Captain James Morrison, the Aberdeen ballistics specialist assigned to evaluate German gunnery technology. Penetration values exceed anything in our arsenal by significant margins. At maximum range, this gun can defeat any known Allied armor configuration. He consulted his measurement instruments with the reverence of a man witnessing technological superiority. The Germans weren't exaggerating their claims. This weapon system represents a quantum leap in anti-tank capability. Wharton operated the Jagdtiger's controls with growing appreciation for German mechanical precision. The transmission responded smoothly to input commands, hydraulic systems functioned within design parameters, and the gun's elevation mechanisms moved with clockwork accuracy. Engineering quality's impressive, he admitted grudgingly, running his hands over control surfaces machined to tolerances that exceeded American standards. Everything works exactly as designed. Germans built this thing like a Swiss watch. Smith observed the testing with mixed emotions, watching American confidence erode as the Jagdtiger demonstrated capabilities that made Allied tank doctrine seem primitive by comparison. If German claims proved accurate, American armored units had been fighting at severe technological disadvantage throughout the European campaign. The implications troubled him. How many American tank crews had died because Allied weapons couldn't match German engineering excellence? But captured combat reports began painting a different picture entirely. Smith opened the intelligence packet containing Otto Carius's unit records, documents that revealed the gap between theoretical performance and battlefield reality. Schwer Panzerjägerabteilung 653, equipped with 10 Jagdtigers, had achieved exactly one confirmed American tank kill during 3 months of combat operations. One kill against losses of 8 vehicles, not to enemy action, but to mechanical failure and tactical abandonment. These numbers can't be right, Morrison protested, comparing ballistic test results against combat statistics. Vehicle performance indicates near invulnerability to Allied weapons. How does a technically superior system achieve such poor operational results? He studied Carius's after-action reports with the confusion of a man whose calculations had been invalidated by reality. German crews reported transmission failures, final drive breakdowns, and fuel starvation, mechanical problems, not combat defeats. Wharton discovered the answer in maintenance logs that read like catalogs of engineering optimism. Final drive life expectancy, 1,500 kilometers maximum. Sherman drives are rated for over 5,000. He traced component failure patterns with a mechanic's practiced eye, finding stress fractures, metallurgical fatigue, and wear rates that indicated fundamental design flaws. They built precision machinery to tolerances that can't handle combat conditions. Everything works perfectly until it doesn't. Then it fails catastrophically. Smith compared German production statistics against American manufacturing data, finding disparities that explained operational paralysis. Germany had produced 80 Jagdtigers over 10 months of maximum effort, allocating resources that could have manufactured 400 Panzerjäger 4 tank destroyers. American factories, meanwhile, had delivered 2,300 M36 tank destroyers during the same period, vehicles with adequate anti-armor capability and proven operational reliability. Operational availability tells the real story, Kowalski observed, consulting maintenance reports from both armies. German heavy armor averages 30% readiness rates, 7 out of 10 vehicles non-operational at any given time. American tank destroyer battalions maintain 78% availability through standardized parts and simplified maintenance procedures. He gestured toward the Jagdtiger, which, despite its impressive firing demonstration, required specialist attention for every mechanical function. Complexity is the enemy of reliability. The mathematics of logistics revealed Germany's strategic blindness with devastating clarity. Each Jagdtiger required 47 specialized components for field repair manufactured to tolerances that demanded precision tooling unavailable at forward maintenance facilities. Sherman tanks used 12 standardized parts that mechanics could fabricate in field workshops or cannibalize from damaged vehicles. German technical superiority had created maintenance nightmares that guaranteed operational failure. Morrison's continued ballistic testing only deepened the paradox. Gun performance remains exceptional across all measured parameters, he reported, watching armor-piercing shells demolish target arrays at extreme range. Accuracy, penetration, and effective range all exceed Allied capabilities by significant margins. This weapon should dominate any battlefield encounter. He paused, studying combat reports that contradicted his empirical evidence. Yet German crews consistently report tactical ineffectiveness due to mechanical unreliability. Smith studied Otto Carius's personal combat memoirs, finding confirmation of operational bankruptcy disguised as technical triumph. Carius described units cannibalizing 3 Jagdtigers to maintain 1 operational vehicle, crews abandoning mechanically sound tanks because recovery equipment couldn't navigate combat terrain, and ammunition shortages caused by vehicles too heavy for standard supply transport. German doctrine had created weapons too sophisticated for the military infrastructure designed to support them. The pattern's consistent across all German heavy armor programs, Smith concluded, comparing Jagdtiger performance against Tiger and Panther operational data. Technical excellence pursued without regard for logistical sustainability equals tactical failure. They built weapons their military couldn't effectively deploy. He watched as the Jagdtiger's crew struggled with a minor hydraulic leak that would require specialized repair facilities to address properly. American doctrine emphasizes reliability and maintainability precisely because wars are won through sustained operations, not individual technical superiority. As Aberdeen's testing program continued, Smith realized the Jagdtiger represented more than German engineering. It embodied a philosophical approach to warfare that prioritized perfection over practicality, creating weapons too complex for the chaos of actual combat.